Hi folks, in this video we are going to summarise the topic of density and kinetic theory, and we're going to try and fit everything we can into the one page. This video is suitable for double award physics and for GCSE Physics. If there's any material that only applies to GCSE Physics, that'll be made clear by using a different colour pen. In this particular topic, there's no higher tier only content, which means everything in this video could appear on either a foundation or a higher tier paper. So to start off with, we're going to have a look at the relationship between mass and volume. So let's say that we had 3 different blocks of the same material, but each of the blocks had a different volume. Would we expect each of those blocks to have the same mass? Probably not. So the 3 blocks that I've drawn here, the first has a volume of 10 centimeters cubed and a mass of 40 grams. The second has a volume of 20 centimeters cubed and a mass of 80 grams, and the third a volume of 30 centimeters cubed with a mass of 120 grams. Now, for us to really investigate the relationship between the mass and the volume and see what connection there is, we need to plot a graph. So we're going to plot a line graph with mass on the y-axis against volume on the x-axis. Once we draw a line of best fit through the points, we see that we get a straight line through the origin. This is really important because what it tells us is that the two quantities on the axes are directly proportional. So the mass is directly proportional to the volume. What this means is if we were to double the mass, then we would also double the volume. If we were to treble the mass, then we would treble the volume. Or if we halved the mass, then we would also halve the volume. Mathematically, we can write this as m is proportional to v. So m is the mass and v is the volume. Now at the minute, that isn't an equation, that's just an expression. So to change this into an equation, we need to replace the proportional sign with equals a constant. So it turns out that in this case, this constant is the density. So the density is basically a way of saying how tightly packed together the particles are in a material. The more dense it is, the more tightly packed together the particles are. Now we could actually calculate what the density of this material is from the graph that we've plotted. The equation that we've got now, where we have mass is equal to density times volume, that follows the layout for a straight line. And the standard equation for a straight line is y is equal to mx. So if we were to plot the mass on the y-axis, which we have done, and we plotted the volume on the x-axis, which again we have done, then the gradient of the graph would tell us the density. So there are a couple of different ways of calculating the gradient of a graph. You might use y2 minus y1 divided by x2 minus x1. So choosing 2 different points on your graph and putting them into that equation. Or you might use rise over run, which is where you find the change in the y-axis and divide it by the change in the x-axis. What we do is we pick 2 points on the line of best fit. They don't necessarily have to be points that were plotted. And from those 2 points, we draw a large right-angled triangle. So if we look at the vertical side of that triangle, that will give us the rise. So we want to figure out how much has it increased by. In this case, the line started at 40 and it finished at 120. So the increase here is 80 grams. The run is equal to the length of the horizontal line. Here we started at 10, we finished at 30, which means the run is 20 centimeters cubed. So we can now put that into the rise over run equation, where the rise is 80 grams divided by the run, which is 20 centimeters cubed, and that gives us an answer then of 4. So what is that for what? What's the unit for density? Well, to figure out the unit of the gradient, we do the same thing with the rise over run although instead of putting in the numbers, we put in the units. So on the rise, we had the unit of grams, and we divided that by the run, where we had the unit of centimetres cubed. Now we usually write this all on the one line, so it would look like this, where we have G for grams / centimetres cubed, and we say that as grams per centimetre cubed. So in this case, the material that we were looking at has a density of 4 grams per centimetre cubed. Another common unit that would be used for density would be kilograms per metre cubed. Now we'll take a closer look at this equation. We have discovered the relationship between mass and volume to give us mass is equal to density times volume. However, that isn't normally how we would come across this equation. Usually we would remember it as density is equal to mass divided by volume. So density can be defined as the mass per unit volume of an object. Density is mass over volume. Now the unit for density will depend on the units that we use for mass and the units that we use for volume. In general, we measure mass in grams or kilograms, and we measure volume in centimetres cubed or metres cubed. Now if the mass is measured in grams and the volume is measured in centimetres cubed, then our unit for density is grams per centimetre cubed. If, however, we measure the mass in kilograms and we measure the volume in metres cubed, then our unit for density becomes kilograms per metre cubed. So it will be important to double check the question to see what units these different quantities are given in. In the exam, you can shorten the equation down to D is equal to M over V. It's really important that for any mathematical questions in the exam that you use the following 4 steps. First of all, always write the equation because there will be credit given for the correct equation. Number 2, put in your substitutions. Any quantities that you know, you put the value in. Just remember to double check the units. Number 3, work out the answer. And number 4, add on the unit if it hasn't already been given. So let's see that in action and have a look at an example. Let's try and work out what is the density of a rock which has a mass of 135 grams and a volume of 50 centimetres cubed. So following the 4 steps we mentioned, number 1, we're going to write the equation. So in this case, we can write D is equal to M over V. Density is mass over volume. Next thing we're going to do is put in the numbers that we know. We're told in the question that the rock has a mass of 135 grams. So in my equation, I'm going to replace the M with 135. We also know that the rock has a volume of 50 centimetres cubed. So I'm going to replace the V with 50. Now we're on step 3, work out the answer. Typing that into a calculator, 135 divided by 50 gives us an answer of 2.7. And the final step, adding on a unit. Well, since the mass was in grams and the volume was in centimetres cubed, then our unit is grams per centimetre cubed. We'll look at some other examples shortly. Next, what we're going to look at is what are the different experiments that you could be asked to describe. So practically, we can determine the density of a regular solid, of an irregular solid, and of a liquid. So you need to be aware of what quantities you need to measure and experimentally how can you get those quantities. If you're asked to describe any of the following experiments, typically they're worth 6 marks. So you need to be careful to make sure that you use proper punctuation, spelling and grammar, particularly with the scientific terms. You could also be asked to make some calculations based on these experiments. So the 3 experiments that you need to know are: how do we work out the density of a regular solid? how do we work out the density of an irregular solid, and finally, how do we work out the density of a liquid. So let's look at the regular solid first. So when we say a regular solid, we mean an object like a wooden block that has a cube or cuboid shape. It has an easy equation that we can use to figure out its volume. So we want to find the density of this block. Because the equation is density is equal to mass over volume, we need to measure the mass and we need to measure the volume. To measure the mass, all we need to do is to put the object onto a top-hand balance. We also need to measure the volume. We can't measure volume directly, but what we can do is measure the length, the breadth, and the height. If we use a ruler and measure the three sides, we can multiply that together and that'll give us a value for the volume. And now we can calculate the density by taking the mass and dividing that by volume. So let's have a look at a calculation based on this experiment. So we have a block which has a mass of 7.5 kilograms and the dimensions of 10 centimeters, 15 centimeters and 30 centimeters. Calculate the density of the block in grams per centimeter cubed. So first thing I'm going to do here is I'm going to write out the equation. Density is equal to mass over volume. So I know that in order to find the density, I need to know these two things. I need the mass and I need the volume. So first of all, begin with the mass. The mass here is 7.5 kilograms. Now if we pay attention to the unit that we're asked to find the density in, it's grams per centimetre cubed. So therefore I need to change 7.5 kilograms into grams. Since there's 1,000 grams in a kilogram, that means we have 7,500 grams. The next thing we want to look at then is the volume. Now if we look at the dimensions we have 15 centimeters, 10 centimeters and 30 centimeters. We can use the equation length by breadth by height. And it doesn't matter which one you refer to as the height or which one you refer to as the length or the breadth. You'll still get the same answer. So I'm going to do 15 multiplied by 10 multiplied by 30. Now these are all in centimetres already, which means my answer will be in centimetres cubed. That gives us 4,500 centimetres cubed. So now that I have these values, I can go back to my original equation and put these in. So the mass was 7,500. Going to divide that by the volume, which is 4,500, and we get an answer of 1.6. Now the calculator actually shows 1.6 recurring, but I'm just going to simplify it down to one decimal place. So we have 1.6, and that is grams per centimetre cubed. So now let's have a look at the next experiment, and that is an irregular solid, to find the density of an irregular solid. So an irregular object is one where we can't easily measure the sides together and multiply them to find the volume. So for example, something like a rock. To find the density, we know we're going to need to find the mass and its volume. Finding the mass is straightforward. All we need to do is put it on a top-hand balance, same as with a regular solid. But to find the volume, we need to take a different approach. We start off with a measuring cylinder that has a known amount of liquid in it. For example, 20 centimetres cubed. It's important that whenever you take the reading, you make sure that you're at eye level so that you get the correct value and that you're taking the reading from the bottom of the meniscus, which is the curve that you get in the water. Once you've recorded the initial volume of water, then you put the rock into the measuring cylinder with the water. It's important to make sure that the rock is fully submerged. It has to be completely covered by the water. Then we take the reading of the new volume. to get the reading of the rock itself, we need to take the final volume and subtract the initial volume. So we're taking the volume of the water and the rock together and subtracting the volume of just the water, and that will leave us with the volume for the rock. We can then use the density equation in order to calculate the density. Finally then, we could be asked to find the density of a liquid. To find the mass of a liquid, we do need to use a top-hand balance like we do with a solid. The problem here is any liquid would need to be put into a container because otherwise it's just going to go everywhere. So we need to know what the mass of the container is as well. We will usually put it into a measuring cylinder because that will allow us to measure the volume as well. So we start off with the top-hand balance, and on top of that we put the empty measuring cylinder, and we record the mass of just the measuring cylinder alone. Then we can fill the measuring cylinder up to a set amount and record the mass of the measuring cylinder and the water together. Now we're only interested in the mass of the water alone, so what we need to do is subtract the original value of the empty cylinder from the value of the cylinder and the water together, and that will give us just the mass of the water alone. We can find out the volume of the water very easily by reading off the value on the side of the measuring cylinder. And of course we can calculate density by using the equation density is mass over volume. So the final thing in this topic that we're going to look at is kinetic theory and how we can use it to explain density. That means we need to look at how particles are arranged within solids, liquids and gases. So all matter is made up of a very large number of these particles or atoms, and it's how these particles are arranged that gives each of the states of matter their properties. So we're now going to look at 3 states of matter. We're going to look at what those properties are and how we can use this kinetic theory, this idea of the particles and how they behave, how we can use that then to describe that. So of the 3 states of matter that we're looking at, solids are the most dense. And the reason they're the most dense is because the particles are extremely close together. They have very little gaps between the particles that make them up. For those of you who are doing GCSE Physics, not double award, there's a little bit more information that's required. So that's the bit that's written here in purple. Not only are these particles very close together, but they have fixed positions. They're not able to move past each other. They stay where they're at. The only thing they're able to do is that they're able to vibrate. So quite often in these diagrams, you'll see little wiggle lines beside them just to show that there is a little bit of vibration there. They're kept in these fixed positions by strong forces. And this explains why solids have a fixed shape and a fixed volume. Liquids are not as dense as solids are, and the reason for that is because the spacing between the particles has increased. There's more gaps in between these particles. So they're less dense than solids, but they're more dense than gases, which have lots of spaces between them. The main difference in terms of the arrangement here is that the particles don't have that fixed arrangement like they do in a solid. They're not in those nice neat rows anymore. They still vibrate, so there'll still be little wiggle lines on the diagram to show that they're moving around, but they can actually move past each other because of these gaps in between them. They also have enough energy to prevent these forces from keeping them in those fixed rigid positions like they do in a solid. So for this reason, we see that liquids have a fixed volume, so it will always take up the same amount of space, but the shape of a liquid can change. And it will always take up the shape of whatever container it's in, always starting from the bottom and filling up. Finally, we have gases. Gases are the least dense because the particles are the furthest apart. They've got really big gaps in between them and they're free to move entirely in any direction. The forces between the particles are weak, and this explains why gases are able to fill whatever container that they're in. So whereas a liquid will fill a container from the bottom up, a gas will spread out and completely fill that container. So gases do not have a fixed shape or a fixed volume. The particles are free to move wherever they like, so we tend to draw quite a few of these motion lines on the particles because they're moving really fast and in all directions. So there we have it. We've got the topic of density as much as we can do on the one page. We started looking at the relationship between mass and volume. We then led that into the density equation. We looked at various experiments that we could do in order to find the density of either a regular solid, an irregular solid, or a liquid. And then finally, we looked at how kinetic theory, the idea that everything's made up of particles, how that can explain the different properties of solids, liquids and gases, and how that relates to density. The next thing to do now would be to have a go at some practice questions or some past paper questions, and hopefully you found some of that useful.